Hi students, this is Mr. Yao. Today we're going to talk about 2.11 where we will learn and review how to solve absolute value equations. So let's start with some prior knowledge. What does absolute value mean? It actually means the distance from 0. And because it's a distance, the next question is, could it ever be negative? The answer is no, because we don't say, oh, you walked like -2 steps. That doesn't work. It can't be negative. Now just some quick calculation for absolute value. First one is 9, second one is 9, third one is 3.5, fourth one is 0. So all the top row, we're just changing all of them to positive. And for E and F, E is actually -2 and F is -3. Now you might be wondering, wait, I thought you just said it should actually be positive because of the absolute value. Yes, they do actually need to be positive. However, this is the part that is the absolute value. So that part becomes a 2. But we do have this negative sign that's outside the absolute value. Has nothing to do with the absolute value. It's just attached. So we still need to attach that 2 in the front, which makes the answer -2. Same thing for F. This part is positive because that's the box. And we do have this negative sign outside. So that still needs to be attached with the 3. So it's -3. For G, the inside is actually a 1. Absolute value becomes still a 1 plus 5, 6. And now you might be wondering, wait, I thought you just said again they should be negative, they should be positive, so I need to change that into a positive. That actually is not right because the absolute value sign is taking whatever the final result is inside and then change that into a positive answer, not just changing all the signs inside. So this part is still absolute value of 1, and then that equals 1. So for H, 18 minus 12, that's 6, absolute value, still 6. Now let's move on. When taking the absolute value of a number, absolute value doesn't care which direction the number is from 0. It only cares about how far it is from 0. With very few exceptions, there are always 2 cases to absolute value problems. Why are there always 2 cases, you might wonder? Because there are 2 directions on the number line. So now, for example, the absolute value equation, let's say it's 3x, the absolute value of 3x equals 12. That is basically asking, when is 3x 12 units from 0? Because again, the absolute value sign means the distance away from 0, and that's saying it's 12 away from 0. As for what is 12 away from 0, that's got to be what's inside, so it's 3x. That's what this actually means. Now let's look at that on the number line. I have a 0 here. Let's say that's my 12, and that's my -12. And it's saying 3x is 12 away, so 3x could be 12, and 3x could also be -12. So if you actually solve for each, that will give you x equals 4. That would give you x equals -4. So that's why we actually have 2 different cases, because on both directions, you could have something that is unit 12, that's 12 units away from 0. So example 1. Well, that's just looking for something that is 2 away from 0, so x could be 2 or -2. Example 2. That's looking for something that is 23 away from 0, so x could be 23, and x could also be -23. Again, whenever you're solving inequality, absolute value, always keep in mind that you're looking for the distance from 0. That's the definition. It will never change for absolute value. Now, number 3, if you think about it, that actually means when is x, because that's what we're looking for. -114 units from 0. And if you think about it, something that is -114 units from 0, well, that actually does not work. So the answer is no solution, because there's nothing that is -114 units away from 0. Now let's solve some slightly more complicated cases. So here are the steps. First, we're going to isolate the absolute value on one side. This actually is the most important step. You do always need to make sure the absolute value is isolated. You can kind of consider this to be a box. You can't have like other things covering it and like hovering around it. You have to make sure to remove everything else that's around it before you can even open the box. So that's why we're going to make sure it is isolated. For this specific example, it is already isolated, so we can move on to the next step. Step 2, break the equations into 2 cases. So to keep your work very organized, let's start making 2 cases. But again, you have to make sure your box is isolated before you can separate the cases. First case, remove the absolute value and just solve. I'm going to remove it, so I have negative 8x equals 64. Second case, remove the absolute value, but this time we're going to need to set the number to be the opposite. So negative 8x is negative 64. Then we're going to solve for each. So this one, after solving, that's going to be negative 8. This one, divide both sides by negative 8. After solving, it's going to be an 8. So again, you might be wondering, wait, I thought you just said absolute value has to be all positive. Then how come you're setting it to be a negative 64? Well, because in this step, I already got rid of the absolute value. If you actually put that negative 64 back into the absolute value, that still gives you a positive 64. So that is already getting away from the absolute value. So last, we do actually want to check our answer. I'm going to show you the checking on some questions to just clarify things. So for this one, I'm going to just plug it back in. So negative 8 times negative 8, which is x. Inside absolute value, that's going to be an absolute value of 64, which is 64. That means we got it right. And for this case, I'm going to replace that x with the 8. So it's negative 8 times 8 inside absolute value, which is the absolute value of 64, which comes out still to be 64. That means we got it right as well. So these are going to be our final answer, negative 8 and 8. Again, to emphasize, absolute value can't equal a negative number. Make sure you are aware of that. Now let's do another example. Example 5. First step, same thing, isolate the absolute value. So this is our absolute value. We're going to need to isolate it. So the negative 6 is like something that's hovering around our box. We're going to need to get rid of it first. So I'm going to get rid of it. Then we got x is actually, the absolute value of x is actually 0. So make sure you actually have this step that you still have the absolute value that equals just something, and the absolute value is by itself. Then you can start separating your cases. So that gives you x equals, well, if you think about it, positive, and we need like a positive 0. We're just going to keep it there. And the other one, x equals, well, now I need the opposite, which is negative. But positive 0 and negative 0 are both just 0. So they both just give you x equals 0. So your final answer is x equals 0. That's example 5. Next, example 6. We still got to do the first step. Your box is right here. So you're going to need to get rid of everything that's around the box. So we're going to need to get rid of the negative 3 by multiplying by negative 3 on both sides. So that is gone. We got just a box on the left side, which equals to negative 36. Now some of you are going to be like, oh, okay, so now I can just start doing set one as negative 36, and the other must just be a positive 36. However, that is not right. The definition said they can't be negative because it is a distance. Because it has a negative and it will never work, the answer is no solution. That's example 6. Now example 7. In comparison with example 6, you might notice, well, this time the negative 4 is actually inside the absolute value. So in that case, this is my box. It is already isolated. So that is still the first question you're going to need to ask yourself. It is. That means I can start setting up the cases. First one, get rid of it. Remove the absolute value sign and just solve it normally. Second case, remove the absolute value sign, but I need to set it to the opposite. So this one, multiply both sides by negative 4. I got x equals negative 128. This one, multiply both sides by negative 4. I got x equals positive 128. Now you might be wondering, oh, so doesn't that just mean I can actually get a negative answer and then I just set it to the opposite number, or vice versa? That actually is not going to be the case. So that's why let's look at number 8. Number 8, the absolute value. First question you're going to need to check with yourself, is it isolated? It is by itself in the box, so it is. We can start setting up our cases. Negative 3m minus 6 is a positive 24. Negative 3m minus 6 is a negative 24. So I'm going to add 6 on both sides. Negative 3m equals 30. M is negative 10. For this one, add 6 on both sides. Negative 3m is negative 18. Divide both sides by negative 3. I got m is 6. And you can see it's not just one answer, then put the opposite number as your other answer. That's not how it works. So if you ever wonder, wait, but I feel like 10 would actually work. Well, let's check. Let's actually put it back in and check. That you would get -3 times 10 minus 6, which is going to give you -30 minus 6. So it's -36 inside the absolute value, which is 36. That is not 24. So that's why you can't just take the opposite number and hope that's an answer. You have to actually set it up and solve it. Now, number 9. First question to ask yourself, is it isolated? In this case, that's my box. It is isolated. So I can start setting up my case over 4 plus 7 equals 3. Or case 2, x over 4 plus 7 equals -3. This one subtract 7 on both sides. X over 4 is -4. So x is -16. This one, subtract 7 on both sides. I got x over 4 equals -10. So x is -40. These are both my answers, and you can see they're not just the opposite number of each other. Next, number 10. My absolute value is right here. So my first question is still to ask, is it actually isolated? The answer is no. So I need to subtract 45 on both sides. So I will get 5x minus 15. It equals to -10. Now it's time to actually make sure you check about the definition. Again, definition for absolute value is distance from 0, so it can never be negative. And we do see a negative sign being set up with the absolute value, so the answer is automatically no solution. There's not even case to set. Next, number 11. You at first might be wondering, oh, isn't this like the same with like b plus 13 inside parentheses? And I can just like distribute. However, absolute value does not work the same as distribution because our goal is still the first step. Is it isolated? The answer is no. So that means I need to get rid of the -8. To get rid of it, you do need to understand -8 is being multiplied with everything, so I need to divide -8 on both sides. That would give me b plus 13 inside the absolute value, which equals 8. So first case, b plus 13 equals 8. In second case, b plus 13 equals -8. After solving, first one, b equals -5. The second one, b equals -21. That's example 11. Next, example 12. First, I need to check, is it isolated or not? The answer is no. So that means I need to add 12 on both sides to actually make sure it is isolated. So x over 7 inside absolute value equals to 60. Now I can start writing my cases because it is separated. One of them is equal to 60. The other equals to -60. One answer is 420. The other answer is -420. Now number 13. My box is here. So first question, same thing. Is it isolated? The answer is no. So I need to multiply both sides by the 4. So this 4 is gone. I got 2y minus 4 equals 72. Now I can start setting up my cases. First one, remove the absolute value, just keep it normal. Second one, remove the absolute value and flip the number. So for this one, add 4 on both sides, 2y equals 76, y equals 38. For this one, add 4 on both sides, 2y equals -68, so y is -34. These are our final answer for example 13. And that is everything for absolute value equations. Thank you.